Hello, Brian here from Desert Fabworks, desertfabworks.com, CNC plasma cutting here in Fort Mojave, Arizona. I want to talk a little bit about the plasma cutting of the AR plates versus water jet or laser. There's a lot of people who have talked about how that using a plasma cutter to cut the AR plates basically destroys the plates because of the heat affected zone, and it changes the metallurgy and makes them brittle on the edges. And so we're going to talk a little bit that. Let you make a decision after this video is done and see what you think. So for our process, obviously we are using CNC plasma. And I'll take and show you where we do the cutting here in just a minute. So on plasma we use an electrical arc, and it takes in, shoots through the plate using a temperature that's hotter than the sun. So you think that, oh yes, that's going to obviously destroy the plate. Well, don't be too quick to jump to a conclusion yet. Let me show you some video in a minute. But with that, we're moving at a very high rate of speed so that that heat is concentrated in a very small area for a very short time. One of the other things that we do is we take and submerge cut our plates. So basically the plate is submerged in water during the cut, which takes and helps pull the heat away quicker so that the heat does not make it into the plate where you're going to be shooting. Now, the term that you'll hear a lot is heat affected zone. That is going to be the zone that is affected by the heat. So if we were using a torch, our heat affected zone would be really wide. With plasma, it's a little bit smaller. With our submerged plasma, a lot smaller. Then we move into laser, which is a little bit smaller. You definitely still have a heat affected zone with laser. Don't let them fool you that there is heat involved during the laser cutting. Now while laser cuts very, very fast at the thinner metals, it's going to cut slower the thicker the material is, and also going to depend on how powerful a laser they're going to use. More powerful laser moves faster. So you don't know how powerful the laser is and how many feet per second. So the heat affected zone can be more than what you'd think with a laser. Water jet obviously going to be the least heat affected zone, but water jet is going to move very slow, and there's going to be an increased cost for that. So heat affected zone is going to be determined by the process and how wide that stretches into the material. I'm going to show you with some video. We're going to take and hold a laser temperature indicator that is going to be right at the edge of the plate so that you can see how that heat moves in, and being right after the cut, and also what the temperature is in the center of the plate in comparison. So let's take a quick look at our plasma cutter where we do this work. Okay, so this is our CNC plasma, and it's a 4x8, and we have the green in there is the water that is dyed with a chemical dye to take and help reduce the amount of UV. We also use a chemical in there called green cut that takes and stops the plates from rusting and puts a protective coating on it after we pull them out. So as you can see in here in the water table, you can see the slats running across there, and that supports the material while the plate sits in the water and keeps the plate cool during the cutting and reduces that heat affected zone. So I'm going to show you a quick video of some cutting that we did, and while it's on a cell phone it's a little bit grainier, but you'll get the idea and you can make a better decision on how the heat actually affects the plates when we cut them this way. Okay, so you can see that I was following the cut right behind the cut, seconds after, with the laser from this infrared heat detector following the cut, and you can see that we hit around like 140 during the cutting process, and then it quickly tapered off if I stopped and held a position after the cut. Now we're about 30 seconds after the cut, and we're at 100, 101, and let's move over here to some of the water close by. And so it's maybe 9 degrees difference between the surrounding water, and that'll continue to taper off from here. We'll pull the pieces out, but as you can see that we went up 40 degrees. 140 degrees is all we went up during the cut process, and that's running at 65 amps during the cut. So let's take a look at some pieces of metal that have been sitting out in the sun for a little comparison. Okay, so here's just a simple piece of steel that I set out in the sun same time I started the cut over on the plasma table. It's just been sitting out here on the concrete. So let's take a look at and see what we're getting for temperatures on this guy here. So 125 the steel and 131 for the concrete, 132. So 125, so really only 15-20 degrees is hotter the plasma cutting than a piece of steel sitting out in the sun, and that's not going to affect that steel and make it more brittle for the shooting process or anything else like that. So I think we can call that whole myth busted, especially when we're using a water bath. Okay, you saw the video, you saw the evidence, you saw how we do it. What do you think? Do you think that our method of plasma cutting really affects the plate that much? I don't think so. Comparatively, if you look at everything else out there, this is going to be a much less expensive option for you. We're not going to translate the cost of a water jet to the consumer, and we're not really affecting the plate that much to where it's going to damage it. We saw temperatures right after the cut, within a quarter of an inch after the plasma passed by, that we were seeing temperatures around 140 degrees. Well, we were seeing temperatures of the plate sitting in the sun of 125 plus. So when you consider 15-degree difference, it's really not that much, and it's really not going to affect the plate that much, especially when you see that the bulk of the plate was 100 degrees or less once we moved away from the cut edge. And it quickly, the entire plate took and went back down to a lower temperature as that water pulled that heat out of it, and it stayed far below what you'd see the plate sitting out in the sun. So there's the evidence. Let you be the judge and see what you think when it comes to buying your plates and whether plasma is really that bad when it comes to AR500 plates. Thanks for watching. Be sure to check us out at desertfabworks.com or on Facebook at Desert Fabworks LLC. Thank you.